Well, hello from Jim's radio shop, and I'm working on this Philips radio. It's something new. Just about everything's something new. And I got a great comment from Andrew. Thanks, Andrew. He's pointing out that there's a particular capacitor which, if it blows, will endanger the audio transformer, and we don't want to blow the audio transformer. There it is right there. Wouldn't want to blow that, because that's pretty much the end of the radio. So he's saying, what's he saying there? He's saying a plate of V4 and grid of V5. Plate of V4, grid of V5. Sorry for all the shaking. Well, here we go. Okay, so there is no V marking on here that I can spot. So yeah, I don't see anywhere where it says tube numbers. So we could guess 1, 2, 3, 4, 5. Well, no. No. Based on Andrew's note, it says anode plate V4 and grid V5. And the issue is blowing the audio transformer. So the concept here would be a little bit of positive voltage on the grid of that tube there, and you get too much conduction through it, and look, it's gonna go whoop, 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 and down through the audio transformer, causing a conflagration. So we can't ever have the grid go positive. We just follow the circuit back. Bingo, there's the capacitor. I can't quite read that. I'll have to look with my own magnifier. But let's just see where that wire is going. Up, over into this. I guess that's supposed to be a triode. The plate of a triode there. It's only 56 volts on one side. So this is a more potent, I guess, part of the tube here. Plate voltage is much higher. Goes blocked by that capacitor. And it appears to be just, I don't know, who knows where that's going. Wow. So I'm pretty sure that's the capacitor in question right there. So, considering the severity of a failure of that capacitor on this radio, we should find it and change it. So I need to know the pin number of the grid on this tube, EBL1. And very handily they've drawn the, oh, what's this? Okay, let me sit down here and take a closer look. Okay, I've got my magnifier here. Let's put it on. And we'll take a better look at these things here. Oh, there, ECH4, EBL1. So, okay, so I can see the second one is the EBL1. And I can see there's a pattern in the way the pins are laid out that you can see. There's 4 at the bottom there that are kind of crowded, and then kind of 2 pairs of 2 floating up, kind of up above. So if I can just spot that kind of shape in here, it looks pretty easy to do. Very easy to do that. Okay. And from that, I should be able to figure out which pin is which. Except I have to count in German, I think. No, they've got them marked by symbols. So let's see. I see a looks like a G2, A, K. I see an M. Not sure what the M would be. A D sub 1 and a D sub 2. Well, that was quite a. That's quite a tube. When you look up here, it's got some diode things happening there. It's a busy tube. So, going back to the diagram, somewhere here, well, what I'm looking for is G1, and I'm not seeing it. Yeah, I don't know. I'm not. Oh, there's G1. Help me, I'm blind. The G1, right there in the middle, it's a cap. Wow, boy. Yeah. If any of you were yelling at me, I couldn't hear you. Okay, so we know where the grid cap is, duh. Yeah. There it is. It's a complex deduction to reach an obvious conclusion. The grid cap is the place where we want to poke around for some voltage. Now, if we follow that wire back. Let's follow that wire back. It is the wire that's moving here. Sorry about that. There. Okay, so it's this wire just behind this yellow. Oh. Yikes. There we go. It's this guy right here. Okay. Now, that's straight wire. So off of him comes a resistor. No, this is a capacitor here. 10,000 picofarad, that's what I believe that is, but gotta watch out because it's a European radio and things are a little different. There's a wire coming off, this one here, comes down into this resistor, 100K ohm resistor. So let's see if we can kind of find that over here. Maybe I could print this bigger next time. Maybe that would be helpful. Okay, so we want to follow out the grid, and right away, oh, look at that! Right away, there's a 1,000. That's all there should be. It should just come out and go through a 1,000 ohm resistor. I don't think that's what I don't think that's what I just saw. Because I see 2 wires coming off back here. Oh, I got the magnifier on so you can get in a little closer. So that connector right there, it's got 2 things coming off it. You can see 10,000 picofarad, and you see this wire coming here, coming down to this resistor. Is that 700K? 700K ohms on that resistor, and then it goes into this rather wild kind connecting of everything, floating in space too. That's just floating out there in the radio. It's very unusual. Okay, so how's that make sense? That doesn't make sense. Okay, so the next conclusion is, what stupid thing are you doing, Jim? Oh, looky. There it is. So that would be the 1000 ohm resistor. Sorry about that. That's right there. 1000 ohm resistor. So we continue the wire, it comes to the capacitor. That's got to be the capacitor. It says point, I can read it now, 0.01. So 0.01, I'll betcha, and I should know, would be the same as a 10,000 picofarad. So that's the capacitor of concern. And that's what we need to check. It looked to be in great shape. It does not look like it's at risk at all. A little drum roll there. Woke me up. I don't know about you guys, but got my attention. Okay. Settle down here, Mr. Camera. That's a little better. The camera stand isn't a tripod, it's the leather case. If any of you have tablets with leather cases or whatever, you'll know what I'm talking about. It's a little bit soft and wobbly, so that's why I get so much camera wobblation when I'm aiming it. So I think we should turn on the radio, put on the voltmeter, and see what we get. And the expected voltage wasn't that great, 65 volts. And here we go. We're gonna switch on current limiting for a moment, and now we're going up to full current. We'll just wait for the. We don't have to wait, do we? Hoping to see 0. I'm reading to the chassis. Minus 3.7. Just read the other side. 56 volts. Oh, it's in the range there. So I'm really not too worried about that capacitor. It's in good shape. Now there could be similar things going on back in the radio further, so why don't we check another one. Blocking capacitor on the grid. Where's that? What? I'd have to study this at length to track them down properly. Okay, yeah, I'd have to study this quite a while. But what we've done by checking the particular capacitor we did is we've protected the audio transformer. I get lots of interesting sounds coming out of this radio while we're sitting here, eh? That's not sounding very good. I gotta get some spray cleaner into that or something. It's very loose and shaky too. Of course, I guess when I get to be that old, I'll be loose and shaky too. Oh, that's right. Yeah, I shot that alignment video, which none of us are ever going to see again. So I did a bunch of stuff here. I wonder if I should repeat it now. So that's pretty interesting stuff right here. Listen to that. Okay, so all that noise you heard, I sat perfectly still and touched nothing and just listened along with you. It's pretty interesting stuff, eh? It has that failing component sound to it. There's some pretty interesting sounds in there. I was kind of getting a kick out of that. So what I'm going to do is I'm going to put the camera back inside with the speaker so you can hear it really clearly, and I'm just going to tap around all over the radio and see if we can identify where any of this stuff is coming from. It could be anything from a loose connection, you know, even in this volume control I'm having trouble with, to resistor or capacitor. Usually in the high voltage circuits to make sounds like that, but it could be almost anywhere. Okay, I know you can't see the whole radio from there, but I'll have to go with that for now. Okay. I'm starting with the volume control. And the tapping is me. It's a microphonic arrangement here with these parts that are not like held down or floating. Look at that. I don't think it's the cause of the crackling. Very sensitive, something. I'm just barely touching these things now. Something's going to blow up right in my face here. Got my nose up to it too tight. Ooh. I'm immediately suspicious of my own work here. Wow. Yeah, it's not easy to isolate the so many things are appear to be affected by just tapping. Something very, very sensitive. Wow. That's a tube socket. That's the tube I took out earlier. Thought I cleaned it up. Maybe I cleaned it up, put it back in, and it was worse off. I'm going to wiggle it a bit. Oh my gosh, I can't touch anything. Oh boy, oh boy. Oh boy, oh boy, oh boy. Okay. Well, I don't know what to say for sure about this. There seems to be, a lot of sensitivity down it. Well, I gotta check all these. I mean, I'm stuck. I gotta check all these components here. At least a lot of them have the value written on them nicely. And see if I can find a, I don't know what to find. Find a dog. I mean, this thing is shorting out inside or something to make all those breakdown crashes. I'm not sure I can find that with my voltmeter. I don't know if you guys can hear what I'm hearing, but that's... I think it's just tube contacts that are bad. I mean, these are bad, right? I mean, this radio is not working properly. It just seems so easy. What about this guy? Huh. Man. No, you know what? The whole radio is... Oh, it could even be some kind of bad grounding between metal parts. Well, I'm left. I'm left not knowing at all what I should be trying to hunt down at this point. Maybe I'll turn my attention to stitching together a few of these videos here and send them out.